Well, g'day guys. We are going to continue our conversation about how we use trigonometric ratios, sine, cos, and tan, to find the lengths of unknown sides in right-angled triangles. Now remember, these only apply when we're working with right-angled triangles. So here's one here. We're given some information about this side. The hypotenuse, we don't know. That's the one we're going to find. We're trying to find the one that's the letter, or the unknown, the pronumeral. And I've got a reference angle of 25 degrees. I know from our previous work on trig ratios, this little phrase here, so katoa, helps me remember the three trig ratios that we're using. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. Now, looking at this triangle, I've got my reference angle here. So this is the opposite side, and this is the hypotenuse. So I've got something about the opposite and the hypotenuse. I have no information at all about the adjacent. So I can't use anything that's got an A in it because I don't have any information. This has to be a sine question. Opposite over hypotenuse. I've got an opposite and a hypotenuse. So let's do that. Sine of the angle, 25 degrees, equals the opposite over the hypotenuse. So 2 over x. Now the x is the bit we're trying to find out. So I'm going to solve this for x. Now, in the previous video, we had the unknown, the letter, on the top of the fraction. And all we did was we dragged the denominator across here in front of the trig ratio. Well, in this case, it's almost as easy. If the unknown is on the bottom, we simply swap it with the trig ratio. We swap the x and the sine 25. Now, it's a shortcut. And towards the end of this video, if you're interested, I'll show you the actual algebra that's going on. But the shortcut it works, and it's just as easy. If the unknown's on the bottom, swap them. So now I'm going to rewrite that. When I swap my x and my sine 25, the x comes up here where the sine was, and the sine 25 comes down on the bottom of the fraction where the x was. I just swapped their positions. That I can put in my calculator. 2 over sine 25, and I get a value of 4.73. So the length of this hypotenuse is 4.73 meters. Congratulations, you just used trig ratios to find the length of the unknown side. Let's look at one more example. I've got a right angle triangle, so I can use sine, cos, or tan. Now, this format here, if you're not familiar with this is 42 degrees and 12 minutes. So every degree is made up of 60 minutes. So if I break 1 degree down into 60 pieces, so this is the format that you might see it in. 42 degrees, 12 minutes. Now we can use these fine in our trig ratios. We just have to use our degrees, minutes, seconds button, and I'll point that out to you in a minute. So let's go ahead and have a look. I'm going to use SOHCAHTOA. It's going to be one of these three ratios. Here is my angle. So I've got an opposite and an adjacent. I have no information at all about the hypotenuse, so I can't use anything with an h in it. It has to be a tan question, opposite and adjacent. So tan of 42 degrees and 12 minutes equals, now my opposite is 6 over my adjacent of m. The unknown is on the bottom, so my little shortcut is I swap the trig ratio and the unknown. I just swap places. So my m will come over here. My tan 42 degrees 12 minutes will go to the bottom of the fraction. Now here's a little shot of my calculator that all you do is you basically put this in as you see it. I actually did it just in the fraction form. I did 6 on the top of the fraction, tan 42 12 degrees, and you have a little button on your calculator here. This little, yours might look like yours may actually just have the letters DMS on it. Depends what calculator you're using. But this stands for degrees, minutes, and seconds. So I put in 42 and I hit that button for degrees. Then I hit 12 and I hit that button again to indicate minutes. And I get my answer of 6.62 centimeters for the length of the hypotenuse. Great job. So just remember that little tweak at the end that says if the unknown is on the bottom, which it was in both of these examples, you simply swap it with the trig ratio. If you're okay with that, you can stop here. But I do want to quickly go through the algebra, just for those of you who want to know, well, actually, you don't just tell me to swap them, show me why the maths works. Well, let's have a look and see how it works. Here's one with the unknown on the bottom. If I swap them, I'll get this, x equals sine 25. Let me walk you through the algebra of what actually is happening behind that shortcut. Here I've got x on the bottom. This is 2 divided by x. Now remember, I'm trying to get x on its own. So to get rid of this x, I can multiply both sides by x, because I'm trying to get rid of this denominator. Okay, whatever I do to one side of an equation, I can do to the other, as long as I do the same thing. These give me x's that I can cancel out. So when I tidy this all up now, I've got x times sine 25 on the left, and I've got 2 remaining on the right. The last step here is trying to get this x on its own. This means x times sine 25. The opposite of timesing sine 25 is divide by sine 25. Whatever I do to one side, I have to do to the other, because now I've got some sine 25s that will cancel out. And when I tidy this all up, I have x on the left-hand side, 2 over sine 25 on the right, and whoa, magic, you'll see that is exactly what we got when we did the shortcut. This is more pure, I guess you could say. It's gone through the actual steps, but you guys do whatever works for you. The shortcut works for me. It's great. All right, last thing I'm going to do is I'm going to give you a couple of examples that you can practice on. So feel free to pause the video here. I'm going to put the solution only up in a second, just the answer, not the working out. Gives you something to have a practice on. If you're doing this in a school setting or in your class, copy these down into your book, have a go at them, show all your working out, have a chat with your teacher if you get stuck. But already I'm going to show you the answers in 3, 2, 1. There are your solutions. So good luck. I hope you went well. Cheers.